Today, I'm very excited to share with you our recent work on the optimal performance feedback in gamified services. First of all, I would like to thank the award committee of Informed Service Science Best Student Paper Competition for selecting this work as one of the finalists. My name is Chen. I'm from INSEAD, and this is a joint work with my advisor, Professor Guillaume Rose. Providing performance feedback is a common practice in many gamified services. Take Strava and Samsung Health, for example. While both of them provide feedback on certain fitness challenges, they do it in different formats. Strava, on the one hand, uses a leaderboard, providing the performance of the leaders. Samsung Health, on the other hand, provides the performance of all users as a distribution. Strava, on top of this, puts a little crown to the leader, highlighting the performance of the best performer. Samsung Health, on the other hand, highlights the performance of the average. On top of these differences in design, they give private feedback differently. Strava tells the focal user their exact rank and performance, while Samsung Health tells the focal user that you are in the top 5%, which is in fact a range. Such feedback also exists in a wide range of daily activities. For example, when we complete a captcha check, they tell us that your speed of completion exceeds 86% of the users. When we wear health trackers to sleep, these track your sleep time and tell you that your sleep time is longer than 30% of the people. If we try to classify the apps mentioned based on their design features, we can basically do it in a 2x2 matrix. First, let's consider captcha. It doesn't have a goal. It doesn't contain share other user scores, and therefore it belongs to the top left cell. And on the other hand, Samsung Health, it shares it has a goal, which is at the average, and it shares other user scores, and therefore it belongs to the bottom right cell. We can also fill in the other two quadrants accordingly. Well, one might wonder, how do setting a goal or sharing other user scores change users' utility? Let's look at them one by one. So when you share other user scores, compared with the GRE score where other user scores are not shared, a user on the lower panel knows not only how many people he's ahead of and behind, but also by how much. And by setting a goal, basically we are changing, users' utility of attaining an additional score will be changed. When they get closer and closer to the goal, they will have a higher marginal value. And once they have passed the goal, the marginal value will suddenly decrease. And therefore, we can accordingly model the user's utility construction as a two-stage process. First, they are going to attach a value function to any score x, depends on whether a goal has been set or not. So if a goal has been set, then the value function will take an S shape based on our discussion in the previous slide. And then after associating a value function to every score, people start comparing with each other through social comparison. So of course, this depends on whether they know other user scores or not. If not, they might give a best guess of other user scores. So what happens here is that no matter other user scores are shared or not, they are going to get utility when they are ahead of others, and they will have this utility when they are behind others. We refer to the first type as being ahead-seeking and the second type as being behind-overs. And therefore, given whether a goal is specified and given whether other user scores are communicated, we are going to let the service provider try to find out the best possible type of private feedback such that users' utilities will be maximized. So now let's look at our key prescriptions. We find that when a goal has not been set, when other user scores are not shared, any information policy leads to exactly the same outcome. That means a captcha check, while a captcha check is optimal when they tell users that their speed exceeds 86 other users, but they do equally well if they don't tell other users this information. Moving down, when other user scores are shared but no goal has been specified, what happens is that the optimal information policy will be transparent if users are more ahead-seeking. It will be fully opaque if users are more behind-overs. Therefore, for the depth-life sleep function, if they think their users are more ahead-seeking, then telling users how they sleep compared with others is the optimal policy. However, if they think their users are behind-overs, then it's no longer the optimal to do so. Moving to the next quadrant. So if other user scores are not shared, but a goal has been set, the optimal policy will be to pull the upper range, which means that we will tell users above a certain threshold, then they are above this threshold and nothing else, like you're in the top 50%. And tell people below this threshold, that's their exact score. So, and this threshold will move with the goal. For example, when in Strava's case, the goal is at the maximum. In this case, the optimal policy converges to a fully transparent policy, which applies to Strava's function, Strava's leaderboard. And finally, when a goal has been set and other user scores has been communicated, the optimal information policy depends on whether users are head seeking or behind the words, depends on where the goal is, and also users performance distribution. But as a general rule of thumb, it is optimal to pull people around the goal when users are head seeking, and pull the entire upper range when users are behind the words. So with this, we hope this prescription helps service providers in designing their optimal information feedback policy to users, depending on their design features and user characteristics. Of course, sometimes whether to set a goal, where to set a goal, and whether to share other user scores, these are also design features. So for this, we refer you to the paper version of this work. Thank you.